Good morning, dear students. I hope everybody has read the gas chromatography lecture. Now we are going to learn the another advanced type of the chromatography, that is high performance liquid chromatography. In this lecture, we should cover the introduction part of the HPLC, the principle involved in the method, various types of the Hplc, and the instrumentation part. We discuss the components involved in the instrument Hplc. What's the learning outcome of this lecture? You will be able to understand the Hplc introduction, the principle involved in the method, the various types of the Hplc, and the components involved in the instrumentation. So what is HPLC? HPLC is the high performance liquid chromatography, or it is also known as high pressure liquid chromatography. It's a modified version of the liquid or the column chromatography. It is the chromatography technique used to separate out the components of the mixture for the purpose to identify, quantify, or purify the individual components of the mixture. This is widely used in the field of biochemistry and the analytical chemistry. So we can say it's an analytical technique used to separate out the components or identifying the components in a mixture by applying the high pressure. That's why it is called the high pressure liquid chromatography. So high performance is related to the high pressure. How much high pressure is required for this chromatography? It is about 4000 to 6000 psi. What is the principle of HPLC? High performance liquid chromatography principle is based on the adsorption as well as the partition phenomena of the chromatography, depending on the nature of the stationary phase. As we all know, there are two types of the chromatography and two types of the principle involved on the basis of the stationary phase selected. If we choose the stationary phase solid, the principle involves the adsorption, the component affinity towards the solid phase. And if the stationary phase is liquid, it is based on the partition phenomena, that is the solubility difference of the components among the liquid phase. So here also these two principles involved. If the stationary phase is solid, the principle is based on the adsorption chromatography, and if the stationary phase is liquid, it is based on the partition chromatography. It is an important for the determination for volatile as well as non-volatile compounds. As we have seen in a gas chromatography, we are very much restricted to have the separation of volatile components. But in this HPLC, non-volatile compounds can also be separated out. It is very important for the determination of qualitative and the quantitative analysis. It is also important for the determination of retention time, the time required after the sample injection, the maximum angle P reaches to the detector. So retention time to the column, we can determine it. We can do the qualitative and the quantitative analysis. So it is helpful for both type of the compounds, purification, identifying, or the separation, that is volatile as well as non-volatile compounds. HPLC can be classified into the various types depending on the type of the stationary phase selected or on the basis of the application. First, we are seeing on the basis of the mode or the type of the stationary phase we have selected. So that can be classified into the two types. The one is normal phase HPLC, which is called normal phase mode also, and the reverse phase HPLC. So what is normal phase HPLC? In which the stationary phase is polar in nature and the mobile phase is non-polar. So if we select our stationary phase, that is polar, and mobile phase, that is non-polar, it is said to be the normal phase HPLC. This is not advantageous for the pharmaceutical application because most of the drugs are always polar in nature. If they are polar in nature and you have selected the stationary phase polar, what it happens? It attracts it and it takes the longer time to come out from the column for the detection. So those samples which are extremely polar, for that if we select the stationary phase polar, so the problem of elution come out. So pharmaceutical application do not use this normal phase HPLC. For that we have the second type of the HPLC, that is reverse phase HPLC, in which the stationary phase is non-polar and the mobile phase is polar in nature. So octadodecyl silane, which is non-polar stationary phase, is used in the reverse phase HPLC. And in pharmaceutical application, we use this reverse phase HPLC because if they are going to be polar in nature, the drugs, they are not retained for the longer time and come out from the column for the detection. After seeing the type of the HPLC on the basis of the stationary phase selected, now we see on the basis of the application, or it is said to be on the basis of elution technique. Elution means the component coming out from the column. On the basis of that, we have two types of the HPLC. The one is isocratic separation and the another one is gradient separation. So what is the difference between these two types of the HPLC? In isocratic separation, or in this technique we can say the same mobile phase combination is used throughout the process. Means the concentration of the solvent or the liquid, which is a mobile phase in this technique, that is same. The same polarity or the elution strength is maintained throughout the process. Only one type of the concentration of the solvent or the mobile phase is used. That type of the HPLC is called isocratic separation or isocratic HPLC. Now, if we go for more than one concentrated solvent, then we have the gradient separation. So in gradient separation or in this technique, a mobile phase combination of the low polarity or the elution strength which is used followed by gradually increasing the polarity or the elution strength. So we have more than one different concentrated solvent. It goes with the lower polarity concentration to the higher polarity concentration. So on the basis of the polarity, we go for making the use of the concentrated solvent in the process, and that type of the HPLC is called gradient. So the difference is simple. If we are not changing the concentration and we are making the solvent with the same polar and the same concentrated which is to be used throughout the process, that is isocratic. And if we are changing the concentration from the low polarity to the high polarity concentrated solvent, we are changing it and use it in the analysis. So that type of the HPLC is gradient. Now we come to the instrumentation part of the technique. This is the HPLC instrument, which consists of the various components. So in the instrumentation part, we should see all the components involved in this HPLC instrument and what is their function in the analysis. In the picture, you are able to see here the two container. This is called the solvent reservoir system, in which the solvent or the liquid phase, which act as the mobile phase in the technique, it is stored in this container. That's why it is called solvent reservoir system. Now this is attached to the HPLC pump. The next component is the pump. Then the mixing unit, the degasser, which is also called solvent degassing, injector by which the sample is introduced, the column where the principle involved and the separation takes place, and the detector. After seeing all the components, then we move towards the whole working process and the analysis in the method. This is the flow diagram of the HPLC system. There you can have all the components which we have talked about, how they are connected to one another. It is easy to see here. The solvent reservoir, in which the solvent is kept as a mobile phase, degasser, HPLC pump, injector. This is the column. Then we have the detector and the recording unit. So the first component in the HPLC instrument, that is solvent reservoir. The solvent reservoir in which liquid or the solvent is stored in it. The solvent which is used in the HPLC, methanol, acetonitrile, water, these are the major solvents or the liquid used in the HPLC. Now, the solvent reservoir component can be divided into two types. The one is binary system. The another one is quaternary system. What is binary system? As you have seen in the picture, the binary system contains two containers or the beakers to store the solvent. If we are having two containers or the beakers in which the solvent must be stored, that type of the system is binary system. So in the picture you have seen that there are two containers, and that type of the HPLC is the having the binary solvent reservoir system. In the HPLC, the another system also having, that is quaternary system. In quaternary system, there are four containers in which we can store our mobile phase or the solvent or the liquid. So in the quaternary system, four containers or the beakers are there, which goes on taking the solvent and the liquid in the appropriate concentration used in the analysis. The next component after the solvent reservoir is the degasser. Degasser is used to purify the solvent or to remove the impurities from the solvent. as several gases are soluble in the organic solvents. When these solvents are pumped under the high pressure in HPLC, it forms the gas bubbles, which will interfere with the separation process. It affects the shape of the peak, steady baseline. That's why the whole analysis is disturbed while having these gas bubbles. It is very necessary to remove these gases as well as the impurities present in the solvent. That's why the degassing is very much necessary of the solvent. That's why this is also called solvent degassing, because degasser, it is used for the solvent. How it is done? The vacuum pump is attached to the degasser to pump out the air or the gas from the solvent. That's why the impurities goes on removing and this degassing function can be occurred. The next component is the solvent mixer. After purifying the solvent from the degasser, it is passed through the solvent mixer for mixing the different proportion of the solvent used for the better separation. As we have seen, there are two types of the HPLC on the basis of the concentration of the solvent we have used, that is isocritic and gradient. So in the gradient we use more than one concentrated solvent. So in the solvent mixer it helps in making the different concentrated solvent for mixing out for the better separation. If we are going to prepare more than one concentrated different solvents, it is useful for the better separation. The next component is the HPLC pump after the solvent mixer. To provide a very high pressure, that is 4000 to 6000 psi, that is pounds per square inch. When this pressure is applied and the sample sent to the column with this high pressure, it exerts the back pressure. The back pressure is exerted by the column. It is due to the resistance of the column, because when we are applying such a high pressure and to the sample and send to the column resists that pressure, and due to the resistance of the column, this back pressure exerts. It is also due to the blockage of the pores inside the column. So the back pressure is exerted due to these two reasons, because column goes on resisting this high pressure, as well as due to the blockage of the pores it exerts the back pressure. The back pressure is low in the new column. If we go for using the new column in the HPLC, we have the low back pressure. But the high pressure is exerted in the used column, the column which is used before. That exert more high pressure because it causes the blockage of the pores. So that's why the high pressure is exerted in the used column. To avoid the back pressure, the purified solvent should be used. How we can avoid the back pressure? Because if the back pressure is very high, the separation is not good, or the resolution of the result is not so good. So for avoiding this back pressure, we have to use new column, as well as the purified solvent can be used. So this is very important when we are applying this high pressure through this HPLC pump. We should see we have to go for using the new column or purified solvent should be used. The sample to be analyzed is introduced with the help of the sample ejector. So after the HPLC pump, we have the sample injector or the sample injection system where we go for introducing our sample in two ways. It can be introduced by applying the high pressure as well as micro syringe is used to introduce the sample. So the sample to be analyzed either directly it is introduced with the pressure we are giving or through the help of the micro syringe. So that's the sample injection system. After the sample injection system, the next component of the instrument is the column. The column is the major part of the instrument where the separation takes place. The column of the HPLC is made up of stainless steel. But in HPLC, we have two types of the column involved. We have seen in the gas chromatography, we have the coiled column. That is the large column used. That is also made up of the stainless steel or a glass, or it can be of a Teflon, a synthetic plastic. Here the difference is in the HPLC, we have two types of the column. The one column is the small size column which is called guard column, or it can also be said as a pre-column. This is very important in the HPLC. So the one of the column which is the small size column, the guard column is, or we can say it, a pre-column. So the small size, it is of about 2 to 10 centimeter size, and the large size column is the analytical column. The separation of the components from the sample takes place in the analytical column. Understood? So the guard column function, it is used before the main column. The main column is the analytical column. So the guard column or the pre-column is used before the main column. The stationary phase is same in both the columns, but we just go for passing through the guard column first of all the sample and see the result. To minimize the contamination or to minimize the accurate result, this is used. So if any kind of the problem we are occurring or any kind of the contamination is there in the sample, it is checked by passing the sample through this pre-column. It do not pass then to the main column where the exact separation takes place. Understood? So we have to check our sample in the guard column. Understood? So if somewhere the problem is there, we should go for removing it from the sample and then it pass through the main column. So its cost is low. So we are not having the problem of destroying the column, because analytical column, which is the main column, It should not be destroyed. So to prevent this main column or the analytical column, this guard column is used. So it plays a very important role. So we see in the next lecture these two types of the column involved with seeing their main functions, including the working of the instrument and analysis with the application. So we will meet in the next lecture. Thank you and take care.